Thank you, boys and girls. I think now you have this right. Of course, 9.2 was to determine the equation of the tangent to the graph of f at x is equals to 1. Of course, you looked at this one yesterday. X is 1. Now you need to find the y value here. You need to find the y value here. How do you determine the y value? You just take 1 and then substitute it where? Substitute it in the original equation where a is 21, b is minus 60, and then c is 43. You have the corresponding y value. And also you need the gradient of that point. It means you must also take 1 now, substitute it in there. In the derivative, where now a is what? Where now a is a minus 60, and now b is, no, where a is 21, and then b is minus 60. Now the value that we'll get there will be there, will be the gradient. Of course, boys and girls, we looked at the equation of the tangent yesterday, and later on this morning we looked at the x value at which the graph has a point of inflection. We said now you need to determine what? You need to determine the second derivative, and thereafter you let it to be 0, and you solve for x. Right, boys and girls, what I want us to look at today most is to say, how do we determine the equation? It is very important. How do we determine the equation? The first question we had 2 turning points, right? The first question we had 2 turning points. Now, what about the second one now? Look at this one, 2013 paper 1, question 9. The function here defined by f at x is equals to x to the power of 3 plus ax squared plus bx minus 2. This function that you see there is defined by f at x. Defined by f at x is equals to x to the power of 3 plus ax squared plus bx minus 2, right, is sketched below. P and R are turning points of f, but we only have P, which is x coordinate is 1 and y coordinate is also 1. We don't know what are the coordinates of R. Right, now 9.1 now says show that a is equals to 1 and b is equals to minus 1. Show that a is equals to 1 and b is minus 1. Of course, boys and girls, now P is a turning point. This is minus 1 here, and this one is a minus 1 as well. P is a turning point. At the turning point, we have the x as well as y. Right? It means what you are going to do, first one is that we know that when we substitute 1 at the original equation, we are going to get the corresponding y value, which is what? Which is minus 1. You substitute minus 1 in the original equation, you get the corresponding y value, which is negative 1. Right, that's what you're going to do. If we substitute now negative 1 to the power of 3 plus a times negative 1 squared plus b multiplied by negative 1 minus 2, then the answer that you are going to get there, it will be minus 1. Then from here now we solve to say minus 1 to the exponent of 3 is a minus 1, then plus minus 1 squared, it's a minus 1 times a is a, then minus b minus 2. Then we simplify this one to say this one now will be what? This one now will be, take b on the other side is a positive b, then we have a, 1 on the other side, minus 1 plus 1 is 0, then minus 2. Right? Yes, boys and girls, b is negative, it is positive when I take it to the other side. Now this one, minus 1 minus 2 is a minus 3. Minus 3 plus 1, it is minus 2. Right, a is still positive. Of course, you can see I have 2 unknown. Of course, I will have to call it the equation number 1. Right, now we have used the first thing that we know to say, if we have the x value at the turning points, to find the corresponding y value, you substitute x in the original to get the y value. Right, now the second one that we know is, of course, if we have the derivative f prime of x, which is equals to what? 3x squared plus 2ax plus bx, right? If we take this one, we substitute what? We substitute minus 1 squared plus 2a times minus 1 plus b. If we substitute minus 1 in the derivative, then our y here, our derivative will be what? Our derivative will be 0. And then, of course, from here now, we are going to have negative 1 squared is 1. 1 times 3 is 3. Then minus 2a minus 2a plus b. Of course, I can take 3 on the other side. That will be 3 is equals to minus 2a plus b. Then I can now name this one to say this is my second equation, right? Now the next thing now we'll say, now let us now substitute equation 1 into equation 2. Why am I saying this one? Because now we know what is b. Our b here is a minus 2. Right, now we go to say 3 is equals to minus 2a plus what is b? Our b is a minus 2. Therefore, when you simplify this one is 2a plus a minus 2, right? Of course, boys and girls, now this one here minus 2a plus a, then we get what? Negative. Yes, we get negative what? We get negative a, right? Yes, now immediately from this one, now we can now move to next to say, let us take this one on the other side. Now we have 3 plus what? We have 3 plus 2. Then the answer there, now it should be negative 3 here, negative 3, of course, negative 3, then the answer then will be negative 1, then negative a here, then now divide by negative 1, divide by negative 1, then a is equals to 1. Right, boys and girls, now let us go back to this one. Remember the first part we said you substitute x to get y as your corresponding y value at the turning points. That is why we have b is equals to a minus 2. Right, now the second one, we find the derivative f prime of x. Then from that one, you substitute the x. When you substitute the x value, the x coordinate of the turning point in the derivative, your y will be what? Your y will be 0. That is 0. Now I have positive 3 here. When I move it to the other side, it becomes negative 3, right? Therefore, we have negative 3 is equals to 2a plus b. That will be the second equation. Therefore, now I can now say we substitute equation 1 into equation 2. It means now in this equation, wherever I see b, then I replace it with a minus 2. Then yes, a minus 3 is equals to minus 2a plus, now our b now is a minus 2. Then we simplify, then we still have negative 3 here. Then of course now when I move 2 on the other side, it is minus 3 plus 2. Then minus 2a plus a, of course it's a minus a. Then I divide both sides by the negative. That is why now a is a positive 1, right? Boys and girls, of course a here as well, they said that we must show that a is 1. Now what is remaining now is to find the value of what? The value of b. Right, now what is it that we are going to do here? We just substitute a in one of the two equations. Therefore, now I can say b is equals to 1 minus 2. Then the answer there will be a negative 1.